Hello guys, hope you all are doing well. Till now, we have looked into blockchain technology concepts like the introduction to blockchain technology, advantages and disadvantages of blockchain technology. Along with that, we have seen about the applications of blockchain technology. And today, let us dive deep into the blockchain technology where we're going to learn about an interesting topic of blockchain technology called smart contracts. Let me start with the definition or a kind of introduction to the smart contracts. A smart contract itself will determine a contract where different entities participate in creating, deploying, and execution of a smart contract. The concept of smart contract was there well before the advent of Bitcoin network. Computer scientist Nick Szabo has outlined the concept of smart contract in his 1996 publication. In fact, he coined the term smart contract more than 20 years ago. The concept of smart contract is not found in the earliest blockchain network, Bitcoin, but it is the main thrust of Ethereum blockchain. Smart contracts require lots of planning, designing, modeling, and well-planned execution. Improper design and coding of smart contract have resulted in significant failures such as DAO hack and parity wallet lockup. It is such a dominant feature in the blockchain. Let's explore the smart contracts in detail with an example. We do use transfer of cryptocurrencies such as a Bitcoin to transfer value from one pair to other in a decentralized network. Now imagine you want to send a gift of some value or an asset to a particular person on a certain date. Then this transaction includes several conditions to be satisfied in order to send gift to that person. The condition may be like the key or the ID of that person and the date and time at which you want to send the asset, or we can call it as a gift. This introduces few conditions, rules and policies beyond which a general blockchain protocol cannot handle. And there comes the need of smart contract. In a nutshell, a smart contract is defined as a digital contract which is executed automatically when certain conditions are met while preceding an operation on a blockchain network. It also adds programmability and intelligence to the blockchain network. The smart contract also represents a business logic layer with the actual logic encoded in a special high-level language. A smart contract embeds functions that can be invoked by messages or function calls. These functions also take few parameters. A business transaction may involve rules, policies, laws, regulations, and other governing context. All these can be maintained using a smart contract when business logics are designed. Smart contracts allow for these real-world constraints to be realized or applied on a blockchain network. Thus, smart contract enables a wide variety of decentralized applications to be implemented on the blockchain networks. In general, smart contracts are written in a special language called solidity language. It contains all kinds of functions which take few parameters and perform computation on provided data on a blockchain and can return the values. This is an immutable piece of code which is deployed on a blockchain network which cannot be changed further anymore.
So, till now we have looked into the theory part regarding smart contracts, right? So now let's get into the demo session of smart contracts. Here, to get or to create any smart contract, we need to get through the IDE called Remix IDE, which is an interface to create your own smart contracts or to execute them or to compile them. So to get to the Remix IDE, you have to type in the URL box like remix.ethereum.org, and then that gets to you to this page. And here you'll find various options to create new files or to open up files which are already existing in your local system. To create a new file, here you can click on the new file section where it will give you a dialog box where you have to type the name of your file, and that may be anything, but remember that it should end with the extension .sol, because as we write the smart contracts in the Solidity programming language, we have to give the extension like .sol and then click OK, then your file will be ready. Now I have a file to demonstrate you with the Solidity language, that is storage.sol. But before going into this, let me just give you a quick glance to this Remix IDE. Here you have the home button, and this is your file explorer where you'll have different kinds of files which are already there or already which are used in this Remix IDE, and this is the place where you'll have the compilation. Whenever you have completed writing a code for in a file in the Solidity language, then you have to compile that file so as to check whether there are any errors or bugs or not. So this is the compilation section, and next you'll arrive with a section where you can run the transactions or the smart contracts. All the smart contracts that are already written and compiled successfully can be deployed and can be run here. So once a smart contract is deployed, it will be ready to run so that we can execute those smart contracts and get the output accordingly. And this is the place where you'll have few plugins. So all these plugins are to do various operations or to extend the availabilities and the reliability of the smart contracts that you have written. And this is the icon which is given to you to adjust the settings of this IDE. And now let's start with our demo part, where I have a file called storage.sol, and this is the one Solidity program which I have written, a simple Solidity program which is intended to store a variable that is given to it and to retrieve the same variable whenever we want. So this Solidity language is a very kind similar to the high level languages that we have learned till now, like C, C++ and all, which again uses some kinds of classes, functions, variables and all. So again here also we'll have variables which can be any kind, like number or string, like that. And even it is very important to remember that always a Solidity program will contain a class in terms of contracts, as we all know that it is a smart contract thing. So contract is very important. Here we are creating a contract which is named as storage, and under this contract I have a variable which can be called as an instance variable, which is a type of number, and that number too have some constraints like unit 256, which means it will be allowing 256 byte, maximum 256 bits of number. And then I have defined a function with the keyword, using the keyword function, and its name is store, whose main purpose is to take a number which is entered by us or by the user and to store that number in the instance variable of that contract. And then I do have another function which is named as retrieve, and this is a public function because anyone in the blockchain network can use this function to retrieve that number. And here it is given that returns is a keyword which is used to specify whether it is returning something, whether that function returns any value or not. Here I am specifying that it returns a number which is of kind unit 256, and then in the function code I am simply returning that number which we want to return. That is a simple code. And remember that it is very important to mention the version of that Solidity program that we are writing. So basically it is very advised to use the version which is very active at the point of time that you are practicing, right? So this is a simple program that I have written. Let's move on and execute this program by simply navigating to this deploy icon, and there you can simply compile it. First, compilation is very important. So once it is successfully compiled, it will show you the right mark, or else if it is not, if there is any mistake, for example, we'll modify this. I'm removing this num, and then I'll try to compile it again. See, there you'll get the mistake. You can see the errors at the bottom of this pane. Here, expected primary expression, this is the error that we got at line number 12. And then let me just give that variable again and again compile it. Then it is successfully compiled and it will show you the green tick here. Then move on and just deploy it. To deploy and smart contracts, you all need an account. So from an account only you can deploy a smart contract. So to deploy on smart contracts, you should have a valid account on the Ethereum blockchain. So this Remix IDE will work on Ethereum blockchain network, and on that, it is by default it will provide you few accounts with specified ethers which are already given to that account. So there are around 100 ethers for this account. I am selecting one account, and it is preferred to copy the account number, and then it is given the gas limit. Gas limit is something which is used to perform few actions on the Ethereum blockchain network. It is used as some uh, value which is taken in turn for providing some kind of services to you, right? And then move on and try to deploy this smart contract. So once you deploy it successfully, here you can see the status of that transaction. Like it is showing a green tick mark which indicates that your deploy of this smart contract is successful. And then moving on, you can see the uh, sources, like whatever you want you can see here, like whatever the functions or variables that you have specified here, all those will be shown here, right? So one is the store function that I have written, and the other one is the retrieve function that I have written. So for this store function, it can take a variable or a number which is a kind of number, and it is ready to take a number which is of kind unit 256. This will use with this function, store function will take that number and it will store in the variable number again. And when you click on retrieve, it will simply retrieve the value which is already given to that store. Now let's continue by giving some kind of value to this function. Like now let's give a value like 75 to the store function and click on store. And then you can observe that the transaction that we have initiated just now by giving the value 75 to this store function have successfully it is done, and it is showing us the successful sign like green tick mark over here. And then when you try to retrieve the same value, you can just click on retrieve button over here to retrieve the value, and then there you can observe the value 75 over here, which is a successful thing. Like whatever we have given, the same value is written over here, right? So you are done, and this is your smart contract, a simple smart contract which is written to just demonstrate about the smart contract and solidity language using this Remix IDE. I hope you all have liked this demonstration, and thank you all.